So I'm given this question that if in equals to 0, 1, xn root of 1 plus x squared dx, I want to show that in will give us 1 over n root 2 minus n minus 1 in minus 2. Then at the end of the day, we'll evaluate I6. So I'll start with this. In is 0, 1 xn over root of 1 plus x squared dx. So basically, this problem will be solved by integration by part, but this is what I will be doing. I will reduce the upper parts this way. I will write it this way over root of 1 plus x squared dx. So if you look at this part of the equation, is actually a standard integral that we know before, which is this half of f prime of x over root of f of x dx. Whenever you see this is equals to f of x plus c. So by this now we can easily see the part that will make our the v part, which is the integrable, easily integrable part, and this will be our u, which is easily differentiable. So u equals to xn minus 1, while dv is x over root 1 plus x squared dx. So from here my du will be n minus 1 xn minus 2 dx, while my v will be root of 1 plus x squared dx. So now my in using integration by part becomes u which is xn minus 1 times v root of 1 plus x squared with the bound 1, 0 minus v root of 1 plus x squared times the u n minus 1 xn minus 2 dx. So evaluating the bounds here, you have 1 times root 2 minus 0 minus 0, 1, which is the bound. Then we get minus 1 out, n minus 1 xn minus 2 times root of 1 plus x squared dx. So at this point, my in becomes root 2 minus n minus 1, which is outside 0, 1 xn minus 2 root of 1 plus x squared dx. So in becomes root 2 minus n minus 1 integral 0 to 1. So I'll be actually doing a manipulation here so that this part of the integral could relate to what we have from the first question, where our 1 over root x squared is at the denominator root of 1. So it's the same idea, just like rationalizing. So now I have in equals to root 2 minus n minus 1 0, 1 xn minus 2 1 plus x squared here dx over root of 1 plus x squared. So in equals to root 2 minus n minus 1 0, 1 xn minus 2 1 plus x squared dx over root of 1 plus x. So I can expand whatever is in the integrand minus n minus 1 0, 1 xn minus 2 over root of 1 plus x squared plus xn over root of 1 plus x squared all into dx. So at the end of it, we have in equals to root 2 minus n minus 1 0, 1 xn minus 2 root of 1 plus x dx plus 0, 1 xn 1 plus x squared dx. So at this point, you can see that our in is root 2 minus n minus 1. And if you look at the first part of the integral, is actually our in minus 2 plus in. So this could be solved further with in being root 2 minus n minus 1 in minus 2 minus n minus 1 in. So we collect like things by bringing in to one side, have in into 1 plus n minus 1 root 2 minus n minus 1 in minus 2. So you have n equals to root 2 minus n minus 1 I n minus 2, and which the last now 1 over n root 2 minus n minus 1 I n minus 2, which is what was required of us to do. So the next part, which is evaluate I6. I6 is 1 over 6 when n is 6, root 2 minus 5 I4. We don't know I4 before, so we need to get the I4. 1 over 4 root 2 minus 3 I2. I also need to get I2. 1 over 2 root 2 minus I naught. Where I naught will now be 0, 1, x is to the power 0 root of 1 plus x squared dx. So 0, 1 over root of 1x. So we can use substitution. You're using x equals to tan theta. So dx will basically be sec squared theta, the theta, and the bounds will change. When x is 1, theta is pi over 4, and when x is 0, theta is also 0. So we now have I naught equals to 0 to pi over 4 sec squared theta, the theta over sec theta. This down part reduces to sec theta. So you now have pi over 4, 0 sec theta, the theta. So at the end of the day, we have that our I naught will give us ln sec theta plus tan theta. That's also a standard integral with the bound pi over 4 and 0. So when you evaluate this, you have ln sec pi over 4 plus tan pi over 4 minus ln sec 0 plus tan 0. So you have I naught equals to ln sec pi over 4 is 2 plus 1 minus ln 1 plus 0. So this part will be 0. So now have I naught is ln root 2 plus 1. So since you have gotten your I naught, so you will put your I naught in I2. So I2 will be now be 1 over 2 into root 2 minus ln root 2 plus 1. So that will be your I2, and we'll do the same thing. I4 will be 1 over 4 root 2 minus 3 over 2 into root 2 minus ln root 2 plus 1, and I6 becomes 1 over 6 root 2 minus 5 I4, which is 5 over 4 into root 2 minus 3 over 2 root 2 minus ln root 2 plus 1. So that is our final answer.